Similar to a fighter jet heads-up display, a precision-guided firearm provides the shooter with visual indicators to aid shot setup and enhance the shooting experience. Just like a fighter jet HUD, the PGF HUD is overlaid into the shooter's field of view in a non-obscuring manner. Typical HUD elements include mode, range to target, populated once the shooter locks onto the target, wind speed manually set by the shooter, battery life, recording time remaining, shot angle, rifle count, compass direction, zoom setting, pressure, and temperature. When you place your tag using the black dot with the blue ellipse representing where the laser rangefinder is pointing, you will see a visual tone around the tag and the range to target. You will see a red dot on your desired impact point, and you will see a blue X representing your firing solution. Even if the tag leaves your field of view, as long as it stays on the image sensor, your HUD will give you yellow arrows to indicate how to get back to your tag. When the shooter arms the system by squeezing and holding the guided trigger, the X turns red. The shooter can then move the red X onto the red dot and the system releases the round. After the tag track exact shot sequence is over, the blue ellipse with a black dot reappears so the shooter can take the next shot. The heads-up display enables each shooter to get the information he needs when and where he needs it to make long-range shots and is an integral part of the precision-guided firearm experience.
Those really smart people out at Sandia Labs have come up with a bullet that doesn't miss. Sandia scientists and engineers have wide expertise in miniature technology, nanotechnology. And the bullet is actually a tiny guided missile. News 13's Scott Daniels has more from the Newsplex.
Dick, this patented design would give superpowers to average shooters. It could change the way American soldiers are trained on the front lines.
This laboratory is about building very, very tiny machines.
James Jones and his team of engineers at Sandia Labs has turned average size ideas and made them enormous by shrinking them down.
The actual one is this dot right there in the middle.
Their newest project, to take a self-guided missile and put it into a .50 caliber rifle. It shoots like a dart. Instead of shooting straight with a spiral motion, it twists and turns to find a laser-pointed target at the end, making up to 30 corrections per second while in the air.
From the sensor, it commands little fins in the back so that the bullet pitches and yaws and turns itself and guides itself towards the laser dot.
In theory, put these into soldiers' machine guns and they'll hit their mark faster with precise accuracy so soldiers can spend less time in a firefight.
We've tested gunpowders to see if we could get velocity, muzzle velocities of military interest. We've tested various electronic components to see if they would survive launch.
The team wants to continue testing to see if the bullet they've spent 3 years developing could help our military. They need a sponsor to take the prototype and manufacture it on a commercial scale. Jones says that's the target they've been aiming for. Research and development grants have taken the project this far. Jones says it's about halfway through being fully developed for commercial use. Back to you.
Okay, Scott, the Discovery Channel and the BBC are planning stories about this Sandia bullet.
Hi, I'm Brad Callen, and in this video, I'm going to show you how anyone can quickly and easily create doodle videos.
Aircraft designer Titan Aerospace unveiled last week its Solara 50 and 60 unmanned aircrafts, the world's first atmospheric satellites, powered by the sun with a mission range of over 4 million kilometers. An atmospheric satellite is a drone that can conduct most of the operations of an orbital satellite, like weather monitoring or Earth imaging, but is less expensive. Solara 50 and 60 can be launched at night using power from internal battery banks. When the sun rises, the solar panels covering the craft's surface store enough energy to allow them to ascend to a position of 20 kilometers above sea level and stay aloft continuously for 5 years without ever having to land and refuel. Despite its massive size, Solara only weighs 160 kilograms and can carry a payload of 32 kilograms. It can cruise at speeds of up to 104 kilometers an hour, about 64 miles per hour. According to reports, smaller versions of Solara have already flown, and Titan Aerospace is planning to start selling operational systems